Hello, my name is Kenneth Oliver and this is Catherine Hewson, and we are cardiac application specialists for the Philips UK ultrasound team.
Today we are going to show you how to use 3DQ Advanced on the Philips EPIQ ultrasound system.
So let's take a look at 3D Quantification Advanced. 3DQA is a semi-automated border detection tool designed for use with 3D dimensional cardiac images in QLAB. For this demonstration, we are using QLAB 10 and a full volume acquired on the EPIQ X-Matrix edition. 3DQA can be used to analyze full volume datasets for a true 3D volume of the left ventricle. Results generated include measures of regional and global function, including ejection fraction and LV synchronicity. For this demonstration, we will navigate through the basic tools. So here we have an acquired full volume dataset of the left ventricle, acquired over 4 beats from a transthoracic echo examination. On your tablet display panel, you will see what QAPs applications are compatible with your dataset. We are going to choose 3DQA. You will see a quad screen with your original cropped volume acquired in the lower right quad. Your short axis is displayed in the blue box, 4-chamber in the green, and 2-chamber in the red. Your 4-chamber view should be in the top left green box. Task 1. Find the end diastolic frame. Confirm the end diastolic frame. Use the left and right indicators. Then align the corresponding MPRs. In the blue box, center the red and green lines. Place the yellow arrow in the short axis view at the center of the ventricular septum in blue quad. And in the red and green boxes, move the vertical lines to center the LV from apex to base. Make sure your vertical lines lie through the apex. When finished, press Next. Task 2. Enter the end diastolic reference points. Place the 5 reference points onto the corresponding apical 4 and 2 views at the mitral annulus and apex. Septum, lateral, anterior, inferior, and apex. Once you place the apical marker, the software automatically tracks the endocardial border. If you require to edit any of the borders, you can bring your cursor over and click the areas you wish to edit. Press Update and then press Finish Edit Border. Then press Next. Task 3. Find the end systolic frame. Confirm the end systolic frame using the left and right indicators. Then click Next. Task 4. Enter end systolic reference points. Repeat Task 2 but with the systolic reference points. Septum, lateral, anterior, inferior, and apex. Edit as required. You now have displayed in the top right your volumetric data in systole and diastole, ejection fraction and stroke volume. The ejection fraction displayed is the EF from the end diastolic frame and the end systolic frame. This is truly a global volume of the whole heart where there has been no apical foreshortening or geometrical assumption and has been validated against cardiac MR. To analyze all the other frames of the dataset, select Sequence Analysis. The software now automatically tracks all the remaining frames between end diastole and end systole. So now let's take a look at the report page. The first page shows a global report, including volume sizes and ejection fraction. Note, the ejection fraction displayed on this report page may differ slightly to the initial ejection fraction, as all the frames within the dataset are analysed, rather than just the end diastolic and end systolic frames. Click now on Regional. Now we are looking at regional timing and volumetric data using a 16-segment model, as the apex is not included. TMSV stands for time to minimum systolic volume, displayed for all 16, 12, 6 or user-selected segments. Click now on Regional Percentage R2R. Now the regional timing data are normalized as a percentage of the R2R interval, allowing serial studies to be compared even with variations in heart rate. Click now on Parametric Imaging. The top bullseye displays timing data which we have already seen on the previous report pages. However, now this information is color-coded. Regions demonstrating normal TMSV are shown in green. Early TMSV is shown in blue, and late is shown in red. The bottom bullseye displays excursion. Imagine a central line from base to apex of LV. Regions moving inwards towards the central line during systole are coloured blue. Regions moving outwards from the central line are coloured red. Any regions which show no movement, for example akinetic, are shown in black. Let's now exit the report page and go back to the main quad screen page. Just left of the quad screen, we have some icons which allow us to enlarge any of the MPR views. Let's make the shell view full size and play the loop. The video controls are seen along the bottom of the display. Go back to the bottom left of the screen and click Reference Mesh, which displays a diastolic mesh outline of the left ventricle. Now click on Segments. Each segment can be identified independently by name, endocardial location, and measurement result. We can also rotate the shell view using our pointer. Now we will pause the loop. Other display options include 3D view, slice plane view, and iSlice view. The iSlice view presents the data as a series of slices similar to cardiac CT slice view. You can manage the number of slices shown, the thickness of the slices, and the range of image data included in the slices. Thank you very much for watching, and I hope you have found this video helpful.